Hello everyone. We are excited to present our project, a cab booking system inspired by real-world platforms like Ola and Uber. I am Santosh and I am joined by my teammates Lokesh and Abhishek. Together, we have developed a scalable object-oriented solution addressing the problem statement provided. Our goal is to create a platform where riders can book cabs seamlessly, drivers can manage their availability, and the system handles the overall ride process efficiently. Let's dive into the design and explain its usage. Before that, we dive into the solution that we want to implement in this low level design of the cab booking system, which is like Ola. The task is to build a cab booking platform that allows the riders to book cabs efficiently. So we implemented the locations and we represented them as the XY coordinates. For example, a rider and a driver each have a unique location on a 2D grid, and the distance between them is calculated using the Euclidean distance, where each one of you know what is the Euclidean distance mean. It is the x1 minus x2 square root plus y1 minus y2 square root and whole together under root. It gives the Euclidean distance of the particular location. So while developing this low level design of the cab booking system, there is a maximum distance that the driver is allowed to travel to pick up a rider. So we had decided that each cab should have only a single driver. So cab sharing is also not being allowed between the multiple riders. The platform supports only one type of cab. For our simplicity, we had decided to keep it as simple as that possible. The application also should follow also followed some of the features, which are the rider should register, the driver should register before he could access the rider, and also their associated cab. So whenever a cab is being driven to a particular location, so we need to update the location of the cab accordingly and dynamically. So we should also allow the drivers to toggle their availability. That means the driver should provide their locality to be seen to the riders, so that they could accommodate the travel to particular location. So we should also enable the riders to book cabs based on the proximity and availability. That means we need to look after the drivers being available in the particular location, and the driver who is nearby to his particular location should be assigned to him, so that the time would be consumed by the rider, so that the booking could be going on very smoothly. And there is the riders would be provided with the ride history, so that he could check what are the rides that he had been taken place, and also what is the fare that he had got during the trip, and several other details. So and also he end the details and finalize the ride details. So whenever the rider accommodates a driver to go to a particular location, the driver drops the particular rider to a particular destination. So the key constraint here is the driver, whenever he accommodates the driver to a particular location, he needs to update the location accordingly. That means whenever the rider books a cab in the location A, the cab driver should take him to the location B. So now the driver should be available to the location B. That means he should be accessible in the location B, where several other riders could access in the particular location B, so that he should be available in that particular location. That means he should change his location accordingly. Now let's dive into the location. So we had decided that we had several many classes that implement several functionality, but the car class, the rider class, and the driver class, which are the foundational classes for this low level design. Now let's dive into the solution which we had created. Our solution focuses on building a modular object oriented system based on three foundation classes, which I had mentioned before. So these are the riders, this is the car, and this is the driver class. So what is the use of rider class? The riders, it represent the customers who book the cabs, but we had to make sure that the rider should register so that he could be seen to the cab driver, so that he could accommodate to take him to a particular location. And next is the driver class. And likewise, how the riders register on the particular platform, the driver should also register on the particular platform, so that he could be available in that particular location assigned to the each driver, sorry, each rider. Now what is the cabs? I mentioned in the key constraint that we had implemented before, that each driver should be containing having only one car. And for the as we decided to take only one type of car in the entire design, so there should be only one type of car, and each car should contain only one cab driver, and there is no multiple bookings. That means two or more riders should not be allowed to take a particular cab. So there exist several other classes, which is the cab manager class, and the ride details, and also location, which is used to depict the particular location of the particular driver or the rider. Now let us see what is the rider class. So the rider class models the user booking the cab. Here there are several fields, which are the name of the rider, which is the ID of the rider, and which is the ID generator, which is assigned to 1, because whenever we see several riders being registered, this ID generator keeps on incrementing, thus providing a unique ID to the particular rider in order to identify him easily. So public rider which is accepting the string name, which is the name of the rider, which is being registered registered before the string dot it is accepting the name of the rider and being assigned to the current object, and this dot id equal to r plus id generator plus plus. So whenever any new rider being registering on this particular platform, there is existing a particular id which is unique to each and every rider, so that he could be easily identified. So why we kept r here? So in order to depict that r1, r2, r3, likewise so on, up to n number of riders could register simultaneously. So public string get name, return name, which is used to depict the name of the rider upon registering. And we could also access the ID which is being assigned to each and every rider through the get method, which is used to return the ID of the rider. So the getters are used to depict and access the variables that we had produced earlier. Now let us dive into the driver class. So driver class accepts name, ID, car, and likewise the ID generator. So it is very similar to the rider class that we had initiated before. Each and every driver should be having a name, a particular ID in order to identify him accordingly, and a particular car. This should be only one type of car. That means one driver should contain only one car, and there should be not more than one type of car, and there should be no multiple booking across the cars. So int ID generator equal to 1. For static, for now we initiated it as 1. Upon registration of the particular drivers, this ID keeps on generating with D, D1, D2 up to n number of drivers upon registering. So this is also type of method which is used to depict the name of the driver, and also it is used to get the name of the car. So these are the several getters methods which is used to return the name of the driver, and which is used to return the ID of the driver, so that he could be easily known at a particular location, so that whoever the drivers that are residing in the particular location could be easily known to the particular user.
Hey everyone, this is Abhishek. Now I'm going to explain about the subsequent part, the remaining classes of our LLD system. The In order to solve the problem booking a cab, we have used three manager classes: booking manager, cab manager, and rider manager, in order to comply the relationship between these three entities: the rider, the cab, and the car. Uh, as he has explained already about the main functionality of those three classes, the main idea of each of these classes I'm going to explain now. Let us go with the rider manager first. Before understanding the rider manager, if we take a situation where we are going to book a cab as a rider, the rider does not have his location with himself. That's the main idea for us, to not to put the location inside the rider class. Instead, we are storing the location whenever he wants to. Like after he's reached a certain position, he wants to put his location on, and based upon that location, the drivers nearby him will be allocated for him for the ride. That's the main idea. Like the rider manager, the booking manager, and the cab manager are like the core part of our application. They are the software that is being used by the rider entity and the driver entity, for the rider to book a cab and for the driver to go to the location of the rider, and from there to serve the ride, and also to end the ride after reaching the destination. It is in the hands of the driver. In order to implement those three core features, we ended up with these three classes. Now let us go with the first class, the rider manager class. The rider manager class is contains of properties like rider details, ride location, ride history, which are the hash maps. Uh, we can also store the rider history as an individual array present in each of the person as an instance variable. Like each person can have their own ride history with themselves, but it is not how it happens in our real life. The history is stored within the app and not with the storage of the that particular person device. That's the core idea behind storing it inside the rider manager. And also the location. The location is also like after he enters into the application only we take the location. That's the idea. The rider details will be useful. The rider details, we have created this map after we realized we might need to use other aspects just rather than using the rider id. Here the key is always the rider id that we have used, but sometimes uh, we had to use the rider object also in order to extract other information about the rider, and for that only we created this rider details map also. Let us go with the methods in the rider manager class. The first method is add ride to history. After a ride has been finished, it will be automatically triggered so that the rider history will be stored inside this map. The rider history takes input takes two keys, like the ride to history takes two parameters. One is this ID, which is the rider ID, and the ride details. Ride details is a class that consists of an object. Like it is a class that can create objects, not create. I mean, we can create a ride details object through this class. uh, it takes these entities, these parameters: who is the rider, who is the driver, how much distance they are going, and what is the price. Yeah, we have a strategy to calculate the price. We have implemented it through a class driver basic price calculator. I'll explain that later. And for the right details class, we have these methods: certain getters and certain setters. Obviously, in order to store and to retrieve, we need this. Even though we create an object, we cannot access these entities because they are private, and that's why we need to pass. We need to create. We had to create these getters, which will be used later on in toString method in order to print it whenever we want to, and get right details function to get the details of the ride. Okay. Next, in order to get the rider history, in order to show it like in the end, we want to see the history, right? And for that purpose, we are using this getter. This is a getter basically. It is retrieving the map, so it is a getter. And the set rider details for ride. This is like the registration process for the rider. As you can see, the main problem steps, like the main problem is to create certain aspects. Like we need to register a rider, a driver, and also all the other things that are mentioned in the requirements. As per requirements, we are creating a method that is used to register the rider, and this method is for that purpose. This update rider location is like whenever a rider wants to book a cab, he will go to a particular place and then he will book the cab, there is a process that will be going on, as my friend said. I'll explain it again. This is for whenever, if you want to know the location of the rider. Say you are a driver and you want to get the location of a rider so that you can go there and pick him up and come back. This will be useful in that man for that purpose. I wrote this. Now let us go to the cab manager, which is the most important, the core part of our problem solving thing. Here it is a big code. I know I should have classified, should have split into certain classes, but I think all of it matters, and that's why I just put it like that. The cab manager is like an interface for the driver to interact with the application. In here, we store the driver details, just like in the rider class we store the rider details based upon the rider id and the rider object. In the same way, if you want to, there is no need to get the details of the driver. Initially we thought like that, but after some time in the development process, we had to know even some other aspects of the driver, and that's why we had to create this map. There is a map for the cab status. For example, say if you are a driver and you are at certain position and you don't want to, like, you did a ride just now and you wanted to rest and not be free for another ride. In that case, he can just put his flag like I am busy, and in that way he will not be shown for the rider, even if he is available near to that rider. uh, Even in here we might think that it can be placed inside the driver class itself, like we have an instance variable saying cab status or the driver status. But the thing is, for a driver, I don't think it is an appropriate method, and it should be placed inside the cab manager. Like there should, for example, if we take a real time situation and we are using a software like Ola or cab booking thing, in there the driver only after he logs in, it is like he's free. It is an automatic process, and for the same purpose, it is not a property of a driver, I suppose, and that's why I had to put it in the cab manager class. Also the driver locations, if the driver wants to, if a rider is booking for a cab, all the cabs that are close by to him should be seen for him, like they should be available for him. And the nearest one among them will be assigned for the rider as per the logic I have wrote. I'll show that. Okay. And all the active rights that are going on right now will be stored in the active rights. This will be useful in order to put the status of a driver as in a ride, so that he'll not be booked for another rider, and also to know that the status of a rider is currently in booking. uh, in that way we'll use the active rights. This is the constructor for that. There are certain methods, uh, mostly setters and getters, and to update it, this is the register driver. As per the problem states, we need to create a registration for the driver, which will be useful in here. In order to update the cab status, we are using a method. So how do we get the cabs, available cabs? There is a mentioning in the problem that for a rider to book a cab, the cab must be available within certain distance. The minimum distance will be decided by the app itself, and for that we have chosen like, the max cab distance will be 10. So all the cabs that are available in the radius of 10 kilometers from the current rider position are like available to him, making sure that they are also free. The cabs are in free state. If they are in riding state or some other states, it is like they are not free and they cannot be assigned to a rider. So the get available cabs is used to fetch all those drivers who are free and are closer to the rider within a 10-kilometer radius, say. I'm just printing the available drivers so that you can see. My friend will explain that how the output will come and all such things. So the get available cabs retrieves all the list of the drivers who are present close by to the rider, and from that we are applying certain strategy in order to assign a driver. Among all these available drivers, we have to select particular driver who will be assigned to the rider so that he can go on a ride. For that, we are defining a strategy. Here, the strategy is a interface. Like the purpose behind choosing this as an interface is there might be several strategies. Like some people might want to have their bookings based upon the experience, and someone is willing to book as per their requirements. Like someone wants to go to a destination faster, and then they might choose different strategy. In keeping that in mind, we put this as a interface. So I have defined a default assignment strategy, which basically searches for the nearest driver among the possible available drivers. It is basically a normal linear search algorithm through which I'm going on repeat, storing the minimum distance from the rider to the driver, and he will be the nearest driver. I'll return that nearest driver. So the get available cabs would return a particular driver who is closest to the rider. There are other aspects of this cab manager class that are really important that you can see while my friend is explaining. Now coming to the final manager, it is like the heart of this application. Booking manager. The booking manager is responsible for booking the ride and also for ending the ride. Ending the ride, in order to book a ride, we need certain parameters like who is the rider, who is the driver, what is the location of the driver. That it means the starting point of the rider, and then the destination. Where does the rider want to go? Based upon this, we book a ride. Here, based upon the initial and the final coordinates, I'm calculating the distance. Distance calculation is a normal thing. Like it is just a, we are taking the coordinates as x y. We are taking the location as a class because, as per the problem has stated, we are supposed to take the distance as x and y coordinates, and the distance between 2 points, it's the same formula: root of x2 minus x1 whole square plus y2 minus y1. That's the same formula I have used here. And the calculate distance is used to retrieve that distance between those 2 points, the rider and the cab. The same distance is used to check who which driver is available closer to the rider also. That comes from this location object, and all the locations that are handled in these classes are in location object itself. By using this class only it was possible. That's why I created this class. And yeah, coming to the price calculation, I also implemented it as an interface. Price calculator is an interface because, yeah, price calculator is an interface which defines a calculate price method. It takes input as distance. It takes input as distance. For example, if you take a scenario where you want to price for the first kilometers, it will be 3 rupees, and for the next remaining kilometers it will be more than that. In such cases, you can just implement this price calculator and then create the logic as per your requirement. For that purpose, I have created the price calculator as an interface. For the problem, for price calculation, I used per kilometer. It will be $10. It is a default basic price calculator Java. In here you can see rate per kilometer is 10, which is defined already, and the distance into will give the total price for the ride. And we are storing all the ride details: the who is the rider, who is the driver, how much is the distance, and the amount for the total ride will be stored in the ride details object. And we are storing all this information into the get active rights. The get active rights method will retrieve us the map, as you can see here, with that contains the key as the driver ID and the object as the ride details. The ride details will have all that information that contains about the ride. It will have all that information. And for the, as as a driver, after he gets in a ride, his status will be on ride, and so he is not free anymore. And if another rider comes into the picture and he wants to book a cab, and he looks out for the drivers, this driver will not be seen. As we have seen in the previous logic, all only those drivers who are nearby and free can be available to that particular rider. I'm just printing it like this. After a ride has been booked, returning this ride details is useful, uh, as you will see in the output, which my friend will say. And the end ride is a function which is used to end the ride for a driver and the rider. For that, we have to update the status of the driver and to remove it from the active rights, that is active rights map that is present in the cab manager. As well as we need to put the status of the driver as free if he wants to. Obviously, if he doesn't want, it's okay. And also, we need to update the location of the driver to the destination address because he's traveling from the initial point to final point. It is only logical to do that. So these are things. If we are trying to end a ride for a rider who is not at all in the active rides, that means one who is not registered and is in a ride, if you want to cancel or end that ride for that person, it is not possible since he is not in rides, right? For that, this condition is to check that thing. If there is a rider in the ride, only then we are able to end the ride for him. If he is not, we cannot. We'll just put it out as no active rides found for him. So this is how the core functioning happens. I hope I covered everything. My friend will tell you the later aspects, how the code works and the thing. The rider tester is a large class which consists of all the information. He'll tell you about this, how it works, and he'll show the output and the test cases. Thank you.
Hello, I am Salakesh. At present, I am going to explain the riders tester as my friends have explained you about the other classes such as the basic price calculator, the driver class, and driver assessment strategy, and the default assessment. This is the main part of the code which we execute in the Java. At first, we are going to start our process by setting up our drivers. These drivers are, and these setup drivers method is in cab manager. First, we have created objects for our cars as car 1, car 2, and car 3, as you can see here, and we have initiated the cars and the car numbers here. And here we are created our objects for our drivers, and we are giving our drivers names and license numbers and registering them in our cab manager. These are our registered drivers in our cab manager. Here we are giving the location and the driver ID to our drivers, all the three drivers which we have created. And this is the status of our drivers, which means the drivers mainly have three statuses: free, on on the ride, or on leave. In free, we can book the riders who are in the free, and on ride drivers couldn't be booked as they are currently are on the ride with the passenger, and the leave passenger are also not considered in our cab manager. Up to here, we have initiated our drivers. Now it comes to our main block of our code in the rider tester. By this main block, the execution of our main process of the Java starts. Here we have created a scanner to take our inputs from our users and scanner class and create a scanner method. And we are also creating the objects of our cab manager, rider manager, and our booking managers. All the three managers, when it comes to the cab managers, it consists of various implementations such as default assignment strategy and allocation of cabs to our available riders. And when it comes to the riders manager, we are giving the riders their locations and the name of the rider, and other stuffs are included in our rider manager and booking manager, which helps us in calculating or terminating our rides and handling them. And of course, we are considering the above riders which we have taken statically in the previous setup riders method. And here we have created two hash maps for our riders. All the riders who used our application are considered in the riders hash map. And active riders are the riders who are currently using our application by to ride to their destination. And we have also have a small interactive menu which contains the main four objectives such as adding our rider and booking them and ending the ride at the end of the destination, and also viewing our rider's history. Of course, every rider has a separate history, and exiting from our application. At in choice, the person will give their own choice from the above interactive menu. And here we are implementing a switch to all the four cases. When it comes to the first case as add rider and the booking rider, you can see that here we are asking first with the started by with the rider's name. And in this rider's hash map, we check that if the rider has been previously using our application. Otherwise, we will set them by using the set rider details for the ride method from the rider manager. Of course, and the rider name is successfully added to our riders list here. And after that, the riders need to give the appropriate coordinates in the XY axis, and we will take those two as our inputs and give them to the setter update rider location. Of course, basically at the starting of the position, the rider doesn't have a particular position in the XY axis. We will give that as a destination, and now we will start the process of our application by selecting the driver who is nearest to the appropriate coordinates. We are considering only the riders within the 10 kilometers range of our rider as the available cabs. Only those riders would be considered in our array of the available cabs, and other riders who are away from our riders XY coordinates are not considered. And here we are going to give our destination of our rider, exactly where we will need to, where the exactly where the rider need to end up. Here, this is used, the rider details is used so that the rider gets an appropriate cost, so that he would know what would be the cost for that particular destination. uh, and if the riders are available, of course the rider would be booked and the process will be continued. When the case 2 is the end of the rider. Here the ride is get cancelled when the rider gives his name, and then we will check that the rider name is in the active riders or not. If the rider name is in the active riders, then we will start by removing the rider from the active riders. As he had reached his destination, he would be entered the rider, and we would remove that ride by using the end ride method from the booking managers class, and the ride would be considered as end. Of course, if the name of the rider is incorrect, then we would give us that there is no active rider in the rider location. This is the part where we very useful, so that we can see the location, all the history of our riders who have used our application. Here also we will start by taking the name of the rider, if and we will check if that rider is in our riders hash map. If the rider is in our riders hash map, then we will return a list from getting the by using the get riders history from the riders manager, which helps us to get our information of the riders, and we will print them by following an for loop array until the end of the history, which means that the history would, until the history is empty, we are going to print all the rides which we have taken so far in our application. Of course, if there is no rider, we will give them there is no rider but regarding that particular history. And this is a part where we would consider as end of the code, which means that the users can exit from the application by clicking on exit of the code. We have created our classes files. Now we are going to implement our public main function of the radar tester. Of course, we have initiated our driver statically, as you can see here. Now we are going to create a add a rider to our riders list, active rider. We are going to create him by a name of Sai, and we are going to give him coordinates of 7 and 7. Here you can see we initially have the three drivers, but here in our array we are going to only consider the two available drivers, as only the driver 1 and the driver 2 are the nearest drivers for our rider side, and the driver 3 is so far, and we are going to select driver 1 because he's available and he's at the status of free, and he is also the nearest one to our rider, and we are going to give him some destination. So rider chooses it. Yes. Here the ride has been booked. Overall distance and the price from the basic price calculator, which our friends have previously explained. And I'm going to create other ride. You can see. I'm going to create it by the name of Abhi. Yes. Uh, for Abhi, I'm going to give him some location as 14. The travel 3 has been chosen as he is the nearest one and of the available the two drivers. And we are going to give him some destination coordinates of 18. Abhi has been insured. And now we are going to end one of our ride. We are going to end the ride for Abhi. Here you can see the ride has been ended for the rider Abhi, and the driver 3 had received the fair price of 56 rupees. So this one has been also added to our history. Now let's look that when we create a new rider as Santosh, and if we take him as 1919 location, as per our knowledge at present, the nearest driver should be the driver who has dropped a B, as he is at present at the destination of 18 and 18. So he should be booked, which is driver number 3. We'll see. Of course, there are two drivers, but the selected driver is driver number 3, which means that after dropping of the rider Abhi, the rider is at the location of 1818, which means the rider location has been upgraded. So let's say he is going back to the destination of 1515 and he goes. Yeah. Now we will check the history for riders. We'll start by checking history of our Sai rider. Of course, the Sai has ended his ride, so he has no history so far. But as per our knowledge, the Raid Rabbi has ended his ride, right? Now check about Raid Rabbi. You can see that Dabi had took a ride with a fare price of 56 rupees for the distance of 5.6 kilometers. So you have seen the implementation of our code. Now we will go. Now we can exit our application. Yes, the program has been ended and it says goodbye. Thank you.